functions are your friends. You do a good job of writing a function. That means that it's a chunk of code. It's no different than any other code that you write in a normal Python program. The only difference is that you've placed it inside of a function, which means that from any other place in your code, you can call the function. It'll do whatever it's going to do, and it will return a value to you, which is actually pretty cool stuff, especially if you're doing something over and over and over again. Okay? Remember, if you put all the functionality into a function, and then you decide to change how it does something, all you have to do is go and change it in the function, and it'll change it, obviously, everywhere you use it. Remember, last time we talked about the world's worst homework, right? And what that was, we were just sorting things. We were sorting everything in the customer record. Their last name, their first name, their middle initial, where they live, their zip code, just all this stuff. And when we ended up coming up with a long list of stuff, and that sucked. But then we went back and we redid it. We used a function for the bubble sort, and we did a little function for printing the stuff out. And then every time we wanted to sort something, all we had to do was do 2 lines. Call the bubble sort, call the print. And that was it. Now the second worst homework in the world said, do everything you just did, just sort it the other way. Which in the original approach that we had, meant that we had to go through like 11 different spots of code and hopefully make the right change 11 different times to get it to work out. But when you're using functions, all we have to do is go to one function, specifically our bubble sort, make one change, and all of a sudden we had homework number 2 done, right? So that was good stuff. But wow, there's even more to functions. Let's take a look at what we've got going on today. Okay, we're going to talk a little bit about parameters. So remember, when you kick off a function, the function gives you the option of presenting it with some gifts. Specifically, you can pass variables to your function. Now what this means is really cool stuff, because it means that your function is effectively a generic function, right? So I will take these incoming values, whatever you happen to pass me, and then I'm going to do a lot of stuff with those values, and I'm going to create an output based on what those values were. And the reason this is so powerful is it means every time you change those incoming values, you'll get a different output value. So you can reuse the function. So when a function is called, variables are created for receiving the function's arguments. These variables are called parameter variables. So you're passing parameters to it. Okay, that's cool. That makes sense. The values supplied to the function when it's called are called the arguments of the call. Just get our vocabulary squared away. And each parameter variable is initialized with the corresponding argument. So at the start of the function running, those variables are now loaded with the values that you sent them. Right. Okay. And then we're off and we're running. And for the rest of that function, it'll have that value until such time as you make a change. Okay. So if you recall correctly, you'd entered into the business of operating the most successful ice cream store in all of Lakeland. Okay? So let's go back and take a look at that. So let's take a look and see what happens when you make a function call. It's not that complex, but it's just a few things are switching around. So you're going to make a function call. My favorite equals select flavor, and you're passing it in the Boolean argument yogurt. And it's like yogurt yes or yogurt no. Okay? So what we're really talking about here is you're going to call the routine select flavor. Fantastic. That's wonderful. So initializing the functional parameter variable, we have one variable that we're passing. It is the Boolean variable yogurt. Hey, we're going to take this and we're going to deposit it into it. So if we take a look down into the actual routine itself, you can see that there's a thing, input, please enter the flavor yogurt that you have. What we're going to do is we're going to get selection is a variable that we're going to put the flavor that we want in. And then we've got this return statement that says return selection. So this variable, the contents of this variable, are what's going to be passed back to the guy who called us, which is here. And what we're going to do is we're going to take the value of selection and we're going to put it into the variable called my flavor. And that's it. That's exactly what a function does. Right? Make sense? Any questions? Okay. What happens the next time we call this function? So remember, every function can be called over and over and over and over and over and over again. And the question is, what about all those variables that were there last? Do we have to do anything with them? Do we have to do any cleanup? The answer is yay. No, we don't. So a new parameter variable is created every single time we call a function. Okay? If we called it before, we threw away all the variables that were used by that function, right? So every single variable that's used by that function exists while the function's running. The moment you hit that return statement, The garbage man shows up, and they've taken all those variables out to the curb, he loads it into his automated truck, he drives off with them, and they are gone forever. It's as though you never ran the function, okay? So in our particular case, we initialized it with whatever the current true or false value of yogurt was, and then the process, the routine, runs, okay? After the second function call is complete, its variables are again removed. So every time you call a function, a whole bunch of variables potentially get made, get used. It's whatever you use during the function. That's great, that's fantastic. You hit that return statement, they're gone. It's like they never existed. Okay. What if you try to modify an argument parameter? So I'm passing in yogurt, I'm going to change its value. No, you can't do that. Okay? We talked about the fact that when a function returns, all of its variables are removed. Any values that have been assigned to them are simply forgotten. In Python, a function can never change the content of a variable that was passed with an argument. So we're passing yogurt in. Yogurt's going to have a value of true or false. Don't try to change the value of yogurt. Python's not going to like that. When you call a function with the variable as an argument, you don't actually pass the variable, just the value that it contains. So we're not actually mucking with it. If you changed it, you would change the value of the other one. Python's not going to be happy. What's it not going to like? So here's select flavor. It has an incoming variable of yogurt. If yogurt is true, then set yogurt to false. Otherwise, set yogurt to true. Stop! No! Don't change the value of yogurt. You passed yogurt in. Don't muck with it. Okay? Return values. Okay. Use the return statement to specify the result of the function. You gave these input parameters. You had this beautiful bunch of code that did magical and wonderful things with it, and now you've got your shiny result. This is the value that you want to pass back. Okay? That's what the return statement can do. You can return the value of any expression. Instead of saving the return value of the variable and returning a variable, it's often possible to eliminate the variable and just return the value more complex. You can put math in that return statement, right? You can put a whole freaking expression that has to be evaluated. Return number of cones wanted times 5 raised to the power of 2. You can go math, that will get evaluated, and whatever that value is gets sent back. Okay? So you don't always have to do return variable name. You can do return anything you want as long as it comes out of the multiple returns. Oh, goodness gracious, it just gets more complicated. So when the return statement is processed, the function's over and it's done with. Okay? But you might not always go back. You might have different values you want to return under different circumstances. No problems with that whatsoever. Every branch of a function should return values. So select flavor, yogurt, we'll go with that. If you're not going to do yogurt, then return no flavor. Okay? If you are going to do yogurt, then say enter your yogurt flavor and then return my flavor. Okay? So in this particular code, there's two branches. If it's not true and if it is true. Okay? And both of these have two separate return statements. You can have as many return statements in a function as you want. Just make sure that you have one return statement on each one of the possible paths. Yep. Multiple returns mistakes. So what happens when you forget to include a return statement on one of these paths? So select flavor yogurt. If not yogurt, then number of no yogurts is incremented. Else, my flavor is enter your yogurt flavor and return my flavor. So what's wrong with that code? We're missing one, right? So if we do this, if not yogurt, oh my God, there's no return. We're screwed. Maybe not. Python's got your back on this one. So what's going to happen is it's not going to report it as an error. Instead, you're going to get this special value called none, which will mess up absolutely everything that you're doing with your return. Okay? And it's just going to say, listen, you forgot to return something, so I took care of it for you. Sloppy coding. Okay, single line compound statements. All right, this is pretty simple stuff, but here's the gist of it. Generally, when we're coding something up like this, if digit equals 1, then return 1. That's how we do it, right? Two separate lines. Single line just simply means that we can do it this way. If digit equals 1, colon, return 1, all in one line. Okay, not that big of a deal whatsoever. The trick here, though, is this only works if you only have one statement associated with that if statement. If the if statement had a bunch of stuff that you were supposed to do if it was true, you can't use this particular technique. If you only have one line there, you can use it, and it's sort of cool because then if you're doing something like this, you can write code that's actually really easy to read, right? If digit equals 1, return 1, 2 is 2, 3 is 3, 4 is 4, all that sort of stuff like that, right? And the whole reason that this works is because if the if statement is true, there is only one statement that you're going to be executing otherwise, right? If there's two, you could use this little upper term. All right, so let's do an example of all this crazy function sort of stuff. All right, so you've agreed to help out some archaeologists who are researching Egyptian pyramids. Oh my goodness, you certainly do have a diverse set of talents, don't you? Okay. You're taking on the task of writing a function that's going to determine the volume of a pyramid, given its height and base length. If you flipped it upside down and filled it with water, how much water would it take? That's what we're going to do here. Okay? So how are we going to do this? Well, let's see. So what are your inputs? How tall is the pyramid? And how wide is it as a base? Now, I think we're going to make an assumption that, we'll talk about that later. Types of parameter values and return values. So the height and the base can both be floating point. That makes sense? Point something or other. And the computed value volume is also going to be a floating point number. All right. We've got two inputs that are floating points. Compute like the average floating point. And this is just a little comment code here. Compute volume of a pyramid is base is square. So it doesn't have to be square, but we're going to make an assumption that the square, that the base of the pyramid is equal on both sides. Okay? So what does our pyramid function call look like? Depth, pyramid volume, because that's a really cool name that we came up with. Okay? And we're going to have two inputs. We're going to have height, and we're going to have base length. Right? So basically, we're going to create a routine that will work for any pyramid. All we need to know is how tall it was and how wide it was on top. All right, so how do you actually calculate the volume of a pyramid? Come on, high school stuff. I don't know. It's like side, arctan of sine. I don't know. There's stuff. You can use that. Give me a calculator. I'll show you. Yeah, right. All right. Internet search reveals this height. 1/3 height times base area. Okay, so figure out how big the base is, 1/3 times side. Okay, cool, we'll do that, okay. Now, it turns out that our base area is actually a square. So the area of the square, I'm sorry, how do you calculate the area of the square? It's side times side, right? All right, using these two incredibly sophisticated equations, we're going to compute the volume for the arguments. All right, so we implement the function body. Function body is actually pretty simple. We're not really talking about rocket science here. So we got depth, pyramid volume. We've got two input parameters, height and base length, colon. All right, so we'll be dropping those values in. So what do we do now? We say base area, which is a brand new variable, is equal to base length, which we got from there, times base length. So basically, we're calculating the area of the square. And we start at the bottom of it. And then we're going to say how many squares we're going to stack on top of it. We're going to return height times base area divided by 3. And notice that we're not returning a variable, we're just returning an expression that we calculate, and whatever that value is, we crank it back.
So when you run this function, does it copy the insert height and base length?
This one does not. This function is everything that you see here. Sure seems like you're going to need some more code, right? Okay, so there's some other magical code someplace else that will actually get these values. But you'll get them, and then it will call this and we'll pass them in. Does that make sense? Good news, let me show you. All right, so let's do some calculations. So how tall was the Great Pyramid, which is like the #1 pyramid if you're into pyramids and stuff like that. So tallest of the cluster of the 3 pyramids of Gaza, the Great Pyramid was originally 146 meters tall. A meter's what, like a yard, right? So we're going to figure this out in feet. What, it's like 3 times 146? Gotcha. So we're talking like, it's basically like 500 feet tall. And I think in a modern building, it's like 14 feet for a story. So 500 feet tall divided by 14, that's 50 plus stories. That's pretty good. All right. But it's lost 10 meters in height over the millennia. Okay, I can't hate when that happens. Erosion and burial of sand. Who knew? Building it on sand, go figure. Contributes to the sinking. The base of the Great Pyramid is about 55,000 meters. Dang, that's got to be some serious football fields, right? I have no idea. But that's gigantic. So here we go. So this is what the code looks like. So pyramid volume, and then, oh, look at this. And then we print, oh, we don't even have to have inputs, potentially, because we know what the values are from this, right? So print volume 146 is how tall it originally was, and 55,000 is the side. And then if we wanted to be really clever, we'd say it's lost 10 meters or 136. So if we ran this, we get the answer to it, right? Ooh, good news, I got to go. Yay! Coincidentally, this code should look very familiar. All right, so we got our comments. Pyramid volume, height and base length. Base area is base length times base length. Return height times base area divided by 3. Here, start the program. Print volume, pyramid volume. So we're going to call this routine. We're going to pass in 2 variables. 146, as we know that's how tall it used to be. 55,000. Then we're going to do the exact same thing. Pyramid volume, once again, 136 and 55,000. We're going to see what the volume is. Would anybody like to guess the volume of the world's largest pyramid? It's really freaking big. All right, so the volume is, oh my God, that's a huge number. And then if it shrunk 10 feet, oh wow, that's not quite as large, but it's still quite a large number, basically, right? So, what did we see? We saw that we called this twice. We got back to 2 values. Is that what a function's supposed to do? Or we now have a little bit of code that if we wanted to, if we had another program that wanted to know the volume of a pyramid structure, we could just copy this code, drop it in, and we'd be good to go. We can move from program to program. We want to do spheres or cubes or squares and pyramids. Now we already got the pyramid part taken care of, right? Great. All right. All right, scope. Scope is actually a really important concept here. Okay? So the question is where can you actually use a variable? Okay, well, if you use a scope, it's what part of the program can you use to access it? Scope of a function's parameter variable is inside the entire function, right? Not a problem with that whatsoever. So define main, print, cube volume. Oh, hey, look, here's cube volume, side length. So side length exists only within this function. If I go back up to main, they have no freaking clue what side length is, right? The scope of that variable is just within the confines of this particular routine function. Okay, local variables, variables defined within a function is called a local variable, which means it only has a life while that function is running. When you're done with the function, local variables get thrown away. So for example, here in this one, sum equals 0. And then we do a bunch of stuff with sum. And then we print out sum. But when we're done with this routine, sum will be thrown away. And sum won't have any exposure to anything else. When a local variable is defined in a block, it becomes available from that point to the end of the function in which it's defined. With kind of perfect sense. Now where things get a little bit weird is when we run into what we call scope problems. Where we define something in some other place and then we try to use it in some other place and it doesn't exist there. So how does this work? Okay. So define main. Side length equals 10. Result equals cube volume. Poop. Now I'm going to get rid of the cube volume. Return side length cubed, and that's what the value is. Well, that's great and that's fantastic, but I didn't pass side length in. And side length only exists there, and yet I'm trying to use it here. So is that going to work? No, because cube volume doesn't have a freaking clue what the side length is. Because side length is a local variable. It's only available to the other one. Well, the easiest thing to do, of course, would be to pass it in as a parameter. There's one other option that you have there, which is to look at it. Variable reuse. So it's a really bad idea, but you can reuse variable names. So I have this main, I'm using result as a variable up there, and I have this square routine, and I'm using result down there. That's fine, they're 2 completely separate variables. They have no interaction with each other. Nothing's going to go on between them. You're going to confuse the bejeebies out of somebody who's reading your code. Because it's going to look like, hey, result, didn't I send that some other place? And the answer is yes, you did, but I'm just reusing the variable name. So yes, you can do it. No, I would not recommend it. Here you go, global variables. All right, so Python also supports what's called local variables. So variables that are defined outside of a function. If you have a variable that you define outside of the function, and you want to use that value inside the function, you can do it. You just have to make it visible to it. So, let's see, if you want to let's see, a global variable is visible to all functions that are defined after it. If you want to make an update to it, then this is what you do. So here I've got this variable called balance. And I would like to make a change to it within this routine called withdrawal. So that's fine, but if I want to make changes to it, I got to declare it as being a global variable. Okay? Once I define it as being global, I can make changes to it, and those changes will be reflected once the function is done. Sort of a sneaky way of making, well, I guess it's the only way of making changes to things, global variables inside of the routine itself. Because remember, I can pass in variables, but I can't make any changes to them, and I will return a result, which is great. But the only way I can make changes to other variables within a routine is to define them as global variables and tell Python that explicitly, I want to change the value of balance in the course of running this. If you omit the global declaration, then the balance variable inside the withdrawal function is considered a local variable. So balance will be able to be referenced, but it's going to be a local variable, which of course means that when this routine withdrawal is done, the value of balance will go poof, and it'll vanish, right? So you won't have done what you thought you were doing. So let's take a look and see what's in your Python toolbox. Exactly what was in it last time, but remember you now have functions available in your Python toolbox, which for you is critical, because in homework number 3, you get to use them. Functions are your friend. That's why we use an app. Alright, so what did we cover today? We talked about parameter passing. We talked about how to return values from a function. And we talked about that pesky little thing called scope of variables, where something's actually being used. So that's okay. I think your brain is now completely full, which is funny because next time we get together, we're going to start talking about files. A great, wonderful place to store a ton of information. Fantastic, guys. We'll do it again next week. Have a great weekend. Watch out for zombies. Question up here. Hang on. Then I'll have to go back and change that. Okay. It's supposed to be 2
It's natural. I thought that zombies with all those holes in their body, I thought they just came out of it. What? Oh yeah, so he still has like a little bit of human.
No.
It's not complete.
A lot of human yesterday.
What's your favorite part of What is your favorite part of the game?
That is yesterday, pretty much. There was more like 11, but so.
I'm actually going to go back because I didn't remember.
I was surrounded by Brady, Dagan, Corey, and Paul. Basically the only kid, or the only zombies.